Five Guys moves thousands of pounds of beef and buns through a supply chain so intense it runs like a high-speed burger machine. Behind every fresh, made-to-order meal is a massive factory system designed to deliver consistent flavor with zero shortcuts. In this documentary, we go inside the operation powering one of America's most iconic burger chains, from raw ingredients to grill-ready perfection. Unlike many fast food chains that rely heavily on pre-cooked, frozen, or highly processed food products, Five Guys has built its entire business model on quality, freshness, and simplicity. That simplicity, however, hides a remarkably complex and carefully controlled supply chain that delivers consistent, high-quality ingredients to thousands of restaurants across the US and internationally. The journey of a Five Guys burger begins not in the kitchen, but at the factory, processing plant, and farm. The most critical component of any Five Guys burger is the beef. The company is famously particular about the type of beef it uses, never frozen, 100% fresh, and containing no fillers or additives. All Five Guys burgers are made from ground chuck, an 80/20 lean-to-fat ratio that balances flavor and moisture retention. The sourcing process begins at the cattle farm. Five Guys works with a network of beef suppliers located throughout the US and Canada, primarily sourcing from ranches that meet rigorous standards for breed, feed, and animal handling. These standards require that cattle are fed a grain-based diet with a strong emphasis on quality and marbling rather than lean meat content. Cattle are raised under conditions that follow USDA guidelines, and many of Five Guys suppliers participate in third-party animal welfare audits. The cattle are processed in USDA-inspected facilities that are required to meet strict sanitation, temperature, and traceability requirements. Upon slaughter, carcasses are dry-aged in chilled holding rooms to develop flavor and improve tenderness, typically for a minimum of 24 to 48 hours, depending on the processor. The next phase happens at industrial meat processing plants, where the chuck sections are broken down and inspected. These plants are not typical slaughterhouses. They're highly automated production environments that specialize in precision meat portioning and grinding. Only specific muscle groups from the chuck are used in Five Guys' blend, and these cuts are separated, trimmed, and visually inspected for sinew, silver skin, and excessive fat content. Once portioned, the chuck is passed through industrial meat grinders equipped with die plates that produce uniform, medium-coarse ground beef. The grinders are chilled to maintain the meat's structural integrity, typically operating in ambient temperatures of 34 degrees Fahrenheit to 39 degrees Fahrenheit. During grinding, the meat's temperature is constantly monitored using inline thermocouples. If the internal temperature of the grind rises above 40 degrees Fahrenheit, the system automatically shuts down to avoid potential bacterial growth. Importantly, no seasonings, preservatives, or binders are added. This is pure beef, ground and immediately formed into patties using hydraulic patty forming machines. These machines compress the ground beef into uniform discs using precision molds that form 3.3-ounce patties, the size used to build each layer of a Five Guys burger. The patties are shaped gently, not compressed too tightly, to retain tenderness and prevent a dense, chewy texture. Immediately after forming, the patties are layered with food-safe paper interleaves and placed into rigid plastic trays, each separated to prevent sticking or pressure damage. These trays are stacked, shrink-wrapped, and labeled with batch numbers, timestamps, and facility codes. Each batch is also linked to its source lot for full traceability. If an issue ever arises, Five Guys can track the beef back to the exact processing date, plant line, and originating herd. Now, perhaps most famously, Five Guys insists on a never-frozen supply chain. This policy presents a significant challenge at scale. Unlike chains that freeze patties for storage and ship them globally, Five Guys must operate a highly synchronized cold logistics system. Once patties are packed, they're loaded into refrigerated trucks operating at 34 degrees Fahrenheit to 36 degrees Fahrenheit. These trucks are equipped with GPS and temperature tracking to ensure compliance with cold chain protocols throughout the journey. The patties are transported to regional distribution centers, often no more than a day's drive from the restaurants they supply. These facilities are designed to receive, inspect, and hold the beef for only a short window, usually no more than 7 days. If any shipment arrives even a few degrees above temperature or outside of its acceptable delivery window, it is rejected outright. From the distribution hub, the beef is delivered directly to Five Guys restaurants in cold-packed containers, where it is stored in the restaurant's walk-in cooler and used within 48 hours. While beef is one pillar of the operation, another critical component handled at the industrial level is the potato. Five Guys fries are almost as iconic as their burgers, and the company is equally obsessive about how they're sourced and handled. The only potato variety used in their fries is the Idaho Russet Burbank, known for its high starch content and firm texture, which allows it to hold up through the unique double frying process that Five Guys uses in-store. At the agricultural level, potatoes are contracted from farms in the Pacific Northwest, with many coming from family-owned operations in Idaho and Washington. Potatoes are harvested in the fall and stored in climate-controlled warehouses known as potato cellars, where temperature, humidity, and ventilation are tightly regulated to preserve them for year-round use. These facilities use continuous air circulation and CO2 scrubbing systems to prevent spoilage and sprouting. The raw, unpeeled potatoes are trucked to centralized packing plants where they are washed, sorted by size, and loaded into breathable mesh sacks. Unlike frozen fries, which are peeled, blanched, and par-fried in industrial plants, Five Guys potatoes remain entirely raw. There is no industrial cutting, freezing, or seasoning. This makes the logistics much more complex, as raw potatoes are sensitive to bruising, sprouting, and microbial spoilage if handled improperly. After sorting and packing, the potatoes are placed on ventilated pallets and shipped in temperature-controlled trucks to distribution centers and directly to restaurants. Each delivery includes information on farm origin, harvest date, and even the potato storage conditions. When they arrive at the restaurant, they're stored in a dry, cool area, often stacked openly near the front of the store, which has become a visual hallmark of Five Guys locations. To recap, the beef is ground fresh, formed, and shipped cold, not frozen, with strict temperature and traceability controls. The potatoes are delivered raw, whole, and unprocessed, ensuring that every step from frying to seasoning happens in-store by hand. These two ingredients alone demand an industrial choreography that's unlike most fast food chains. And this is just the beginning. With the beef patties and fresh-cut fries prepared and shipped under cold chain precision, the next essential ingredient in the Five Guys burger system comes into focus: the bun. Unlike the patties and potatoes, which are either ground or cut at industrial scale, the buns are crafted in high-output bakeries designed to balance handcrafted quality with the consistency needed to serve thousands of locations daily. This stage of production, though it may seem simple on the surface, involves rigorous formulation, batch precision, fermentation control, and timed logistics to ensure that every burger bun meets the brand's exacting standards. Five Guys uses a proprietary bun recipe, one that's softer and slightly sweeter than standard hamburger buns. This isn't a generic bakery item. It has been formulated specifically to absorb the juices of fresh patties while remaining sturdy enough not to disintegrate during handling. The dough is made daily in regional bakeries contracted exclusively by Five Guys, meaning that each region has its own centralized baking partner to keep delivery times short and the product ultra fresh. The bun dough starts with a mix of enriched wheat flour, water, yeast, sugar, whole eggs, salt, and soybean oil. A small amount of dough conditioner, such as ascorbic acid or enzymes, may be included to regulate gluten strength and improve shelf stability for the short duration these buns spend in transit. Every ingredient is loaded into massive spiral or planetary mixers capable of handling several hundred kilograms of dough per batch. These mixers operate under batch control systems that log ingredient weights via integrated floor scales. Dough temperature is regulated using chilled water injection and jacketed mixing bowls to keep yeast fermentation in check, especially during high output shifts. Once mixed, the dough is allowed to rest for a brief pre-fermentation phase, often referred to as bench rest. This allows the gluten network to begin developing while gas bubbles from yeast fermentation begin forming. From there, the dough is conveyed to a divider rounder system, an automated machine that portions dough balls and gently shapes them into smooth rounds using mechanical cups or centrifugal motion. The precise size is critical, as Five Guys buns must fit the patty exactly, with no overhang or shrinking during grilling. The standard target weight for each bun is usually between 78 and 82 grams, with tolerances of less than +1 g. Once portioned, the dough balls are loaded onto proofing trays and transferred into a temperature and humidity-controlled proofing chamber. This chamber mimics the conditions of a traditional proofer, around 90 degrees Fahrenheit and 85% humidity. Inside, the yeast activity causes the dough balls to rise and expand, forming the signature airy texture of Five Guys buns. This proofing stage usually lasts 45 to 60 minutes, depending on ambient conditions and bakery altitude, with real-time CO2 monitoring systems in place to fine-tune time adjustments. After proofing, the buns are topped with sesame seeds using mechanical seeders positioned just above the conveyor. The trays then enter the baking oven, a long, continuous belt oven heated by convection and radiant sources, set typically between 375 degrees Fahrenheit and 425 degrees Fahrenheit. Each bun passes through the oven on a belt that moves at a consistent speed, completing the bake in about 12 to 15 minutes. Internal product probes are used to confirm that each bun reaches a core temperature above 190 degrees Fahrenheit, ensuring full gelatinization of starches and proper set of the protein matrix. Once baked, the buns move through a rapid cooling tunnel to bring their internal temperature down to below 90 degrees Fahrenheit as quickly as possible. This prevents moisture condensation within packaging and stabilizes the product for transport. Cooling too slowly could encourage mold growth or collapse the bun's structure. The cooled buns are then passed to an automated slicer that splits each bun horizontally, preparing it for use in restaurants. The slicing is done with oscillating serrated blades that operate in sync with the belt speed to avoid tearing or compression. The sliced buns are carefully packed into breathable plastic sleeves, typically holding 6 to 8 buns per pack, and then into cardboard cartons. These cartons are labeled with batch numbers, bakery codes, timestamps, and use-by dates. The target shelf life is short, usually no more than 5 days, including shipping and storage time in line with Five Guys' no freezer policy. Because the buns contain no artificial preservatives, they require tight turnaround from production to consumption. Logistically, the buns are shipped daily from bakeries to distribution centers and then to restaurants. Many bakeries operate overnight shifts to ensure that fresh buns can be delivered in the early morning hours for that day's service. Trucks used for transport are not refrigerated. Five Guys moves thousands of pounds of beef and buns through a supply chain so intense it runs like a high-speed burger machine. Behind every fresh, made-to-order meal is a massive factory system designed to deliver consistent flavor with zero shortcuts. In this documentary, we go inside the operation powering one of America's most iconic burger chains, from raw ingredients to grill-ready perfection. Unlike many fast food chains that rely heavily on pre-cooked, frozen, or highly processed food products, Five Guys has built its entire business model on quality, freshness, and simplicity. That simplicity, however, hides a remarkably complex and carefully controlled supply chain that delivers consistent, high-quality ingredients to thousands of restaurants across the US and internationally. The journey of a Five Guys burger begins not in the kitchen, but at the factory, processing plant, and farm. The most critical component of any Five Guys burger is the beef. The company is famously particular about the type of beef it uses, never frozen, 100% fresh, and containing no fillers or additives. All Five Guys burgers are made from ground chuck, an 80/20 lean-to-fat ratio that balances flavor and moisture retention. The sourcing process begins at the cattle farm. Five Guys works with a network of beef suppliers located throughout the US and Canada, primarily sourcing from ranches that meet rigorous standards for breed, feed, and animal handling. These standards require that cattle are fed a grain-based diet with a strong emphasis on quality and marbling rather than lean meat content. Cattle are raised under conditions that follow USDA guidelines, and many of Five Guys suppliers participate in third-party animal welfare audits. The cattle are processed in USDA-inspected facilities that are required to meet strict sanitation, temperature, and traceability requirements. Upon slaughter, carcasses are dry-aged in chilled holding rooms to develop flavor and improve tenderness, typically for a minimum of 24 to 48 hours, depending on the processor. The next phase happens at industrial meat processing plants, where the chuck sections are broken down and inspected. These plants are not typical slaughterhouses. They're highly automated production environments that specialize in precision meat portioning and grinding. Only specific muscle groups from the chuck are used in Five Guys' blend, and these cuts are separated, trimmed, and visually inspected for sinew, silver skin, and excessive fat content. Once portioned, the chuck is passed through industrial meat grinders equipped with die plates that produce uniform, medium-coarse ground beef. The grinders are chilled to maintain the meat's structural integrity, typically operating in ambient temperatures of 34 degrees Fahrenheit to 39 degrees Fahrenheit. During grinding, the meat's temperature is constantly monitored using inline thermocouples. If the internal temperature of the grind rises above 40 degrees Fahrenheit, the system automatically shuts down to avoid potential bacterial growth. Importantly, no seasonings, preservatives, or binders are added. This is pure beef, ground and immediately formed into patties using hydraulic patty forming machines. These machines compress the ground beef into uniform discs using precision molds that form 3.3 ounce patties, the size used to build each layer of a Five Guys burger. The patties are shaped gently, not compressed too tightly, to retain tenderness and prevent a dense, chewy texture. Immediately after forming, the patties are layered with food-safe paper interleaves and placed into rigid plastic trays, each separated to prevent sticking or pressure damage. These trays are stacked, shrink-wrapped, and labeled with batch numbers, timestamps, and facility codes. Each batch is also linked to its source lot for full traceability. If an issue ever arises, Five Guys can track the beef back to the exact processing date, plant line, and originating herd. Now, perhaps most famously, Five Guys insists on a never-frozen supply chain. This policy presents a significant challenge at scale. Unlike chains that freeze patties for storage and ship them globally, Five Guys must operate a highly synchronized cold logistics system. Once patties are packed, they're loaded into refrigerated trucks operating at 34 degrees Fahrenheit to 36 degrees Fahrenheit. These trucks are equipped with GPS and temperature tracking to ensure compliance with cold chain protocols throughout the journey. The patties are transported to regional distribution centers, often no more than a day's drive from the restaurants they supply. These facilities are designed to receive, inspect, and hold the beef for only a short window, usually no more than 7 days. If any shipment arrives even a few degrees above temperature or outside of its acceptable delivery window, it is rejected outright. From the distribution hub, the beef is delivered directly to Five Guys restaurants in cold-packed containers, where it is stored in the restaurant's walk-in cooler and used within 48 hours. While beef is one pillar of the operation, another critical component handled at the industrial level is the potato. Five Guys fries are almost as iconic as their burgers, and the company is equally obsessive about how they're sourced and handled. The only potato variety used in their fries is the Idaho Russet Burbank, known for its high starch content and firm texture, which allows it to hold up through the unique double frying process that Five Guys uses in-store. At the agricultural level, potatoes are contracted from farms in the Pacific Northwest, with many coming from family-owned operations in Idaho and Washington. Potatoes are harvested in the fall and stored in climate-controlled warehouses known as potato cellars, where temperature, humidity, and ventilation are tightly regulated to preserve them for year-round use. These facilities use continuous air circulation and CO2 scrubbing systems to prevent spoilage and sprouting. The raw, unpeeled potatoes are trucked to centralized packing plants where they are washed, sorted by size, and loaded into breathable mesh sacks. Unlike frozen fries, which are peeled, blanched, and par-fried in industrial plants, Five Guys potatoes remain entirely raw. There is no industrial cutting, freezing, or seasoning. This makes the logistics much more complex, as raw potatoes are sensitive to bruising, sprouting, and microbial spoilage if handled improperly. After sorting and packing, the potatoes are placed on ventilated pallets and shipped in temperature-controlled trucks to distribution centers and directly to restaurants. Each delivery includes information on farm origin, harvest date, and even the potato storage conditions. When they arrive at the restaurant, they're stored in a dry, cool area, often stacked openly near the front of the store, which has become a visual hallmark of Five Guys locations. To recap, the beef is ground fresh, formed, and shipped cold, not frozen, with strict temperature and traceability controls. The potatoes are delivered raw, whole, and unprocessed, ensuring that every step from frying to seasoning happens in-store by hand. These two ingredients alone demand an industrial choreography that's unlike most fast food chains. And this is just the beginning. With the beef patties and fresh-cut fries prepared and shipped under cold chain precision, the next essential ingredient in the Five Guys burger system comes into focus: the bun. Unlike the patties and potatoes, which are either ground or cut at industrial scale, the buns are crafted in high-output bakeries designed to balance handcrafted quality with the consistency needed to serve thousands of locations daily. This stage of production, though it may seem simple on the surface, involves rigorous formulation, batch precision, fermentation control, and timed logistics to ensure that every burger bun meets the brand's exacting standards. Five Guys uses a proprietary bun recipe, one that's softer and slightly sweeter than standard hamburger buns. This isn't a generic bakery item. It has been formulated specifically to absorb the juices of fresh patties while remaining sturdy enough not to disintegrate during handling. The dough is made daily in regional bakeries contracted exclusively by Five Guys, meaning that each region has its own centralized baking partner to keep delivery times short and the product ultra fresh. The bun dough starts with a mix of enriched wheat flour, water, yeast, sugar, whole eggs, salt, and soybean oil. A small amount of dough conditioner, such as ascorbic acid or enzymes, may be included to regulate gluten strength and improve shelf stability for the short duration these buns spend in transit. Every ingredient is loaded into massive spiral or planetary mixers capable of handling several hundred kilograms of dough per batch. These mixers operate under batch control systems that log ingredient weights via integrated floor scales. Dough temperature is regulated using chilled water injection and jacketed mixing bowls, to keep yeast fermentation in check, especially during high output shifts. Once mixed, the dough is allowed to rest for a brief pre-fermentation phase, often referred to as bench rest. This allows the gluten network to begin developing while gas bubbles from yeast fermentation begin forming. From there, the dough is conveyed to a divider rounder system, an automated machine that portions dough balls and gently shapes them into smooth rounds using mechanical cups or centrifugal motion. The precise size is critical, as Five Guys buns must fit the patty exactly, with no overhang or shrinking during grilling. The standard target weight for each bun is usually between 78 and 82 grams, with tolerances of less than +1 g. Once portioned, the dough balls are loaded onto proofing trays and transferred into a temperature and humidity-controlled proofing chamber. This chamber mimics the conditions of a traditional proofer, around 90 degrees Fahrenheit and 85% humidity. Inside, the yeast activity causes the dough balls to rise and expand, forming the signature airy texture of Five Guys buns. This proofing stage usually lasts 45 to 60 minutes, depending on ambient conditions and bakery altitude, with real-time CO2 monitoring systems in place to fine-tune time adjustments. After proofing, the buns are topped with sesame seeds using mechanical seeders positioned just above the conveyor. The trays then enter the baking oven, a long, continuous belt oven heated by convection and radiant sources, set typically between 375 degrees Fahrenheit and 425 degrees Fahrenheit. Each bun passes through the oven on a belt that moves at a consistent speed, completing the bake in about 12 to 15 minutes. Internal product probes are used to confirm that each bun reaches a core temperature above 190 degrees Fahrenheit, ensuring full gelatinization of starches and proper set of the protein matrix. Once baked, the buns move through a rapid cooling tunnel to bring their internal temperature down to below 90 degrees Fahrenheit as quickly as possible. This prevents moisture condensation within packaging and stabilizes the product for transport. Cooling too slowly could encourage mold growth or collapse the bun's structure. The cooled buns are then passed to an automated slicer that splits each bun horizontally, preparing it for use in restaurants. The slicing is done with oscillating serrated blades that operate in sync with the belt speed to avoid tearing or compression. The sliced buns are carefully packed into breathable plastic sleeves, typically holding 6 to 8 buns per pack, and then into cardboard cartons. These cartons are labeled with batch numbers, bakery codes, timestamps, and use-by dates. The target shelf life is short, usually no more than 5 days, including shipping and storage time in line with Five Guys' no freezer policy. Because the buns contain no artificial preservatives, they require tight turnaround from production to consumption. Logistically, the buns are shipped daily from bakeries to distribution centers and then to restaurants. Many bakeries operate overnight shifts to ensure that fresh buns can be delivered in the early morning hours for that day's service. Trucks used for transport are not refrigerated, but the buns are loaded in temperature-controlled staging areas and packed in sealed corrugated boxes to maintain freshness during transit. Any deviation in delivery, timing, or packaging temperature triggers a rejection at the restaurant level. In store, the buns are stored at room temperature in designated bread racks, often rotated using FIFO principles. Staff members are trained to inspect buns visually and by touch. Any signs of excess firmness, moisture, or spotting lead to immediate disposal. Each bun is hand-prepared on-site, toasted on a grill with a light coating of melted butter before it becomes the vehicle for the burger build. This final touch, though simple, is only possible because of the structural integrity and texture delivered by the bakery's industrial process. Now that the core components of a Five Guys burger are accounted for, the beef, the fries, and the buns, it's time to examine the supporting elements that complete the burger experience: bacon, cheese, toppings, and condiments. These items may seem simple, but each is chosen and prepared with deliberate intent and, in most cases, centralized at an industrial level before being delivered to restaurants. Starting with bacon, Five Guys sources thick-cut, naturally smoked strips from approved pork processors in the US. The bacon is not fully cooked at the factory. Instead, it's partially cooked or pre-rendered to about 60 to 70% doneness, then chilled and vacuum packed in clear plastic pouches. These pouches are labeled and sorted by weight and count per case, with each case tagged for traceability. The bacon is cooked to completion in the restaurant, where staff lay it flat on the grill and crisp it to order. This two-step process, initial industrial cooking followed by final preparation, ensures food safety, flavor development, and grease reduction. Every fry that ends up in a McDonald's restaurant has been through a rigorous process, ensuring consistency in taste, texture, and appearance. The company relies on specific varieties of potatoes, primarily the Russet Burbank, Russet Ranger, Umatilla Russet, and Shepherdie. These potatoes are chosen for their high starch content, which helps create that signature crispy exterior and fluffy interior when fried. They are also selected for their long, uniform shape, which allows McDonald's fries to be consistently straight and evenly sized. Farmers who grow potatoes for McDonald's work under strict guidelines to meet the company's high standards. The soil must be rich in nutrients, well drained, and have the right pH levels to support optimal potato growth. Before planting even begins, farmers carefully prepare the land. The soil is tilled and aerated to improve its structure, allowing the roots of the potatoes to spread evenly. Proper soil preparation ensures that the potatoes will grow uniformly in size and shape, which is crucial for creating the perfect fries. Once the soil is ready, seed potatoes are selected. These are not actual seeds, but small, specially chosen potato tubers that will sprout and grow into full-sized potato plants. Farmers cut these seed potatoes into pieces, making sure each piece contains at least 1 or 2 eyes, the spots where new growth will emerge. These seed pieces are then treated with an antimicrobial solution to prevent disease and are left to cure for a short period before being planted. When the conditions are right, typically in early spring, the seed potatoes are planted in long, evenly spaced rows using precision planting machines. These machines ensure that each seed piece is placed at a consistent depth and distance from the others. Consistent spacing allows the plants to develop evenly, preventing competition for nutrients and ensuring that each potato grows to an optimal size. As the potato plants grow, they require constant monitoring and care. Farmers use irrigation systems to provide a controlled amount of water, ensuring that the plants receive enough moisture without becoming waterlogged. Too much water can lead to rot, while too little can cause the potatoes to develop poorly. Advanced irrigation systems, including center pivot sprinklers and drip irrigation, help maintain the perfect balance. Pest control is another crucial factor. Farmers use integrated pest management techniques, which combine natural predators, crop rotation, and selective pesticide application to keep harmful insects at bay. Keeping pests under control prevents damage to the potatoes and reduces the need for excessive chemical treatments. Throughout the growing season, McDonald's suppliers test the potatoes for starch content, sugar levels, and overall quality. These tests help ensure that the potatoes are developing the ideal characteristics for frying. Potatoes with too much sugar will turn dark when fried, while those with too little starch won't develop the crispy texture that McDonald's fries are known for. When the potatoes reach maturity, typically after 90 to 120 days, the leaves and stems of the plants begin to wither and die. This signals that the potatoes underground are ready for harvest. However, before harvesting begins, farmers often use a technique called vine desiccation. This involves cutting or chemically drying the potato vines to toughen the skins of the potatoes and make them more resistant to damage during harvesting. Harvesting is done using specialized potato harvesters. These machines carefully dig into the soil, lifting the potatoes while shaking off excess dirt. The potatoes are then conveyed into large storage bins or directly into trucks for transport. To minimize bruising and damage, the harvesters are designed to handle the potatoes gently, using soft conveyor belts and cushioned drops. Once harvested, the potatoes undergo a crucial curing process. This involves storing them in temperature and humidity-controlled environments for several weeks. The curing process allows minor cuts and bruises to heal and strengthens the skins, improving their storage life. During this time, the potatoes are kept at a carefully maintained temperature, typically between 45 degrees Fahrenheit and 50 degrees Fahrenheit, to prevent sprouting and spoilage. After curing, the potatoes are stored in massive, climate-controlled storage facilities. These storage units can hold millions of pounds of potatoes and are designed to keep them in optimal condition for months. Proper ventilation is key, as too much humidity can cause mold and rot, while overly dry conditions can cause the potatoes to shrivel. Before the potatoes are transported to processing facilities, they undergo another round of quality control. Samples are taken and tested for defects, size consistency, starch content, and sugar levels. Any potatoes that don't meet McDonald's strict standards are either sent for use in other food products or discarded. Only the best potatoes make it through to the next stage of the process. Now that the potatoes have been grown, harvested, cured, and stored, they are ready for transport to the processing facilities, where they will be transformed into the famous McDonald's fries. Specialized trucks equipped with temperature control systems transport the potatoes to ensure that they remain in perfect condition during transit. The logistics of transporting millions of pounds of potatoes require precise planning to ensure a steady supply of raw materials to processing plants. Upon arrival at the processing facility, the potatoes are unloaded and undergo an extensive inspection process. Workers and automated scanning systems check for any potatoes that might have developed defects during storage or transport. Any potatoes that fail the inspection are removed from the production line. The selected potatoes are then sent into the processing area, where the transformation into fries begins. The next step in the process is cleaning. The potatoes are loaded onto conveyor belts and passed through a series of high-pressure washers and rotating scrubbers. These machines use powerful jets of water and mechanical brushes to remove any remaining dirt, debris, and residual pesticides. The goal is to ensure that the potatoes are completely clean before they are peeled and cut, which removes additional sugars and further improves the final texture. This step also ensures that the fries achieve their signature golden color when cooked. Now that the potatoes have been washed, peeled, cut, and blanched, the next critical step in their transformation into McDonald's French fries is the drying process. This stage is essential because excess moisture can interfere with the frying process, preventing the fries from achieving the crispy texture that customers expect. After blanching, the fries emerge wet with a thin layer of surface moisture. If this moisture isn't removed, it will cause the fries to absorb too much oil during frying, resulting in a greasy, soggy texture instead of the signature crispiness. To prevent this, the fries are conveyed into an industrial drying system cooking process before they move on to the freezing stage. Now the fries are ready for individual quick freezing, a process that ensures they remain fresh and retain their texture during transportation and storage. Unlike traditional freezing methods, which can cause ice crystals to form and damage the structure of the fries, IQF rapidly freezes each fry in just seconds, preventing clumping and preserving the ideal texture. As the fries move through the freezing tunnel, they are kept in constant motion to prevent them from sticking together. This ensures that when they are later packaged, they remain separate and can be easily portioned at McDonald's restaurants. The IQF process is one of the most important steps in the production of McDonald's fries. as it allows the fries to maintain their signature quality even after being stored and transported over long distances. Without this rapid freezing process, the texture and flavor of the fries would degrade before they ever reach the restaurants. Now that the fries are frozen, they are ready for packaging. The frozen fries are conveyed to the packaging area, where they are portioned into pre-measured bags. The packaging process is highly automated, ensuring precision and consistency. As the fries enter the packaging machines, they pass through electronic weighing systems that measure out the correct amount for each bag. The machines are programmed to fill bags of different sizes, depending on whether they are destined for restaurants or retail sales. Once the correct amount of fries has been portioned, the packaging machine seals the bags using airtight, food-safe plastic. The sealing process is crucial as it prevents moisture and air from reaching the fries, which could cause freezer burn or spoilage. Each bag is then labeled with information such as batch numbers, expiration dates, and storage instructions. These labels ensure that the fries can be tracked throughout the supply chain and that restaurant staff know how to handle them properly. With the fries now packaged, they are moved to storage freezers, where they remain at sub-zero temperatures until they are ready to be shipped to McDonald's locations worldwide. These massive freezers are designed to keep the fries at a stable temperature, preventing fluctuations that could affect their quality. To maintain efficiency, McDonald's employs a sophisticated inventory management system that tracks the movement of frozen fries from production facilities to distribution centers and, ultimately, to individual restaurants. This system ensures that restaurants always receive fresh shipments and that the fries are used in a first-in, first-out manner to prevent older stock from lingering in storage. Now that the McDonald's fries have been frozen and packaged, the next critical step is their transportation and storage. Ensuring that the fries maintain their quality from the factory to McDonald's restaurants worldwide requires a highly coordinated logistics system. Every detail, from temperature control to packaging integrity, must be carefully managed to prevent any compromise in taste, texture, or safety. Once the fries are sealed in airtight bags and labeled, they are transferred into large freezer storage facilities within the processing plant. These storage freezers maintain a consistent temperature of around -18 degrees Celsius or lower, preventing ice crystal formation, which can degrade the fries' texture. The storage rooms are equipped with high-efficiency cooling systems that circulate air evenly, ensuring that no section of the storage area fluctuates in temperature. Inside these freezers, the fries are stacked onto pallets, which of packaged fries. Each pallet is organized based on batch numbers and production dates, ensuring that inventory follows a first-in, first-out rotation. This method ensures that the oldest batches are always shipped out first, preventing any fries from sitting in storage for too long. Once ready for distribution, the pallets of frozen fries are loaded onto refrigerated trucks. These trucks, known as reefers, are specially designed to transport perishable goods over long distances without breaking the cold chain. Before loading, drivers and logistics personnel conduct a thorough inspection of the truck's refrigeration system to ensure that it maintains the required sub-zero temperatures throughout the journey. As the fries are transferred from the freezer storage to the trucks, time is of the essence. The fries must remain frozen at all times, so the loading process is highly efficient. Warehouse workers use forklifts to move entire pallets of fries onto the trucks in a carefully coordinated sequence. The doors of the truck are kept closed for as long as possible to prevent warm air from entering. And once loading is complete, the truck's refrigeration system is double-checked before departure. Throughout the transportation process, temperature sensors continuously monitor conditions inside the truck. These sensors send real-time data to logistics teams, who can track the temperature remotely and intervene if any issues arise. If the temperature rises even slightly above the acceptable range, Alarms notify the driver and logistics managers so that corrective actions can be taken immediately. McDonald's fries travel through an intricate global supply chain, often covering thousands of miles before reaching their final destination. Some shipments are sent directly to regional distribution centers, while others may be shipped overseas using refrigerated cargo containers. In the case of international shipments, frozen fries are loaded into specialized shipping containers equipped with advanced cooling units. These containers ensure that the fries remain at the proper temperature even during extended voyages across oceans. Once the fries arrive at a McDonald's distribution center, they are unloaded and immediately placed into cold storage warehouses. These facilities operate similarly to the freezer storage in processing plants, maintaining sub-zero temperatures and using the FIFO inventory system. The fries remain in these distribution centers until they are scheduled for delivery to specific McDonald's restaurants. At this stage, delivery trucks equipped with refrigeration units transport the fries from the distribution centers to individual McDonald's locations. These trucks are designed for short-haul deliveries, ensuring that the fries remain frozen while en route to the restaurants. The loading and unloading process is again handled with precision, minimizing exposure to warm air to maintain the fries' frozen state. When the fries arrive at a McDonald's restaurant, they are immediately placed into a walk-in freezer. These freezers, located in the back of the kitchen, are maintained at a constant temperature of -18 degrees Celsius or lower. McDonald's staff follow strict protocols when handling frozen fries, ensuring that the cold chain remains intact. To manage inventory efficiently, McDonald's employees use a stock rotation system that ensures older batches are used first. Staff are trained to check expiration dates and packaging integrity before moving fries from the freezer to the cooking area. If any package shows signs of damage or thawing, it is discarded to maintain quality and safety standards. With the fries safely stored in McDonald's freezers, the next stage of the process begins: preparation and cooking. When an order for fries is placed, restaurant staff retrieve a bag of frozen fries from the freezer and transfer it to the fry station. The fry station is equipped with multiple deep fryers, each filled with a specially formulated blend of oils that have been carefully designed to give McDonald's fries their signature taste and texture. Before frying, the fries are measured out using a portioning system that ensures consistency across all orders. This portioning system dispenses the correct amount of fries into a stainless steel fry basket, preventing over or under portioning. Consistency is a crucial factor in McDonald's operations, ensuring that every customer receives the same high-quality product, whether they are ordering fries in New York, Tokyo, or London. Once portioned, the fries are submerged into the hot oil, which is maintained at a precise temperature of around 345 degrees Fahrenheit. The restaurant fryers are equipped with built-in temperature sensors that continuously monitor the oil and make automatic adjustments to keep it at the optimal frying temperature. If the oil becomes too hot, the fries can burn and develop an unpleasant taste. If the oil is too cool, the fries will absorb too much oil, becoming greasy and soggy. The frying process typically lasts for approximately 3 minutes, during which time the fries undergo a dramatic transformation. The high temperature causes the moisture inside the fries to rapidly turn into steam, creating the crispy outer layer that defines McDonald's fries. Meanwhile, the starches inside the fry undergo gelatinization, giving the interior its signature fluffy texture. To ensure even frying, McDonald's fryers use automated timers and shaking mechanisms that periodically agitate the fry baskets. This prevents the fries from clumping together and ensures that every fry is cooked to perfection. Once the fries have finished frying, the baskets automatically rise out of the oil, allowing excess oil to drain. At this point, the fries are still extremely hot and must be handled with care. They are immediately transferred to a stainless steel holding tray, where they are given their final touch: seasoning. McDonald's fries are seasoned with a precise amount of salt, which is evenly distributed using a specialized shaker. The amount of salt added is carefully calibrated to ensure that every fry has the same level of seasoning. Too much salt can overwhelm the delicate flavor, while too little can leave the fries tasting bland. The fries are then transferred to their final serving containers, whether that be a small, medium, or large fry box. McDonald's packaging is designed to retain heat while allowing some airflow to prevent the fries from becoming soggy. The packaging process is also highly standardized, ensuring that every order looks and feels the same. Ensuring that every McDonald's fry meets the company's exacting standards requires an extensive quality control process at every stage of production. From farm to fryer, each step is carefully monitored and tested to maintain consistency in taste, texture, and appearance. These rigorous quality control measures are essential in producing fries that are identical in every McDonald's restaurant worldwide. It all begins at the potato farms, where McDonald's agronomists work closely with farmers to oversee crop development. Soil conditions, irrigation levels, and growing techniques are constantly evaluated to ensure that the potatoes develop the right starch content and texture for frying. Once harvested, samples from each batch are tested for size, shape, sugar content, and moisture levels. Only potatoes that meet McDonald's specifications are approved for processing. At the processing facility, automated optical sorters inspect the potatoes before they enter production. These machines use advanced imaging technology to detect any imperfections such as bruising, rot, or irregular shapes. Any potato that does not meet quality standards is removed from the line. As the potatoes move through peeling, cutting, blanching, and drying, additional checks ensure that each fry maintains the correct dimensions, moisture balance, and uniformity. One of the most critical quality control steps occurs during par frying. Sensors in the fryers constantly measure oil temperature and frying time to ensure that the fries develop the correct texture and color. Samples from each batch are taken and tested for oil absorption, crispness, and interior fluffiness. If any deviations are detected, adjustments are made to the frying parameters to maintain consistency. Once the fries are frozen, further inspections take place. Random samples are pulled from production batches and tested in lab conditions to ensure that freezing has not affected their texture or flavor. Fries are fried, tasted, and measured for crispiness, color, and moisture retention. Any irregularities result in adjustments to processing equipment or procedures. During transportation, strict temperature monitoring ensures that the fries remain frozen at all times. Sensors in refrigerated trucks and shipping containers provide real-time temperature data, ensuring that any fluctuations are immediately addressed. If a shipment experiences even minor temperature inconsistencies, it may be rejected to prevent compromised product quality. Upon arrival at McDonald's restaurants, employees perform additional checks before storing the fries in freezers. Staff are trained to inspect packaging for any signs of damage or thawing. When preparing fries for customers, they follow precise cooking procedures, including setting timers, checking oil temperatures, and following strict portioning and seasoning guidelines. To further ensure quality, McDonald's conducts random in-store testing. Quality control specialists visit restaurants to sample fries and evaluate their texture, taste, and temperature. These evaluations help identify any potential issues in the cooking process, ensuring that customers receive the perfect fries every time. The chickens destined for KFC facilities are selected from specific poultry farms that follow stringent guidelines set by both KFC's corporate standards and local regulatory bodies. These farms raise broiler chickens, a breed specifically developed for rapid growth and high meat yield, particularly in the breast and thigh areas. To ensure consistency in texture and flavor, the birds are typically grown under controlled feeding regimens with strict monitoring of their diet, environment, and health status from hatchery to harvest. Once the birds reach the appropriate weight and age, usually between 5 to 7 weeks, they are transported live in temperature-regulated, well-ventilated trucks to the processing facility. Upon arrival, the birds are unloaded through an automated conveyor system and transferred to a staging area that uses dim lighting and gentle sound cues to keep the animals calm. This pre-processing environment is crucial for maintaining meat quality, as high stress can cause conditions like pale, soft, and exudative meat, or dark, firm, dry meat, which are both unsuitable for KFC's strict quality requirements. The first critical step in the factory is stunning, which is done using controlled atmosphere stunning, a method that introduces carbon dioxide in gradually increasing concentrations to render the chickens unconscious. This technique is widely considered more humane and helps preserve the quality of the meat. Once the birds are unconscious, they move to the next stage, where an automated system makes a precise incision to the neck, ensuring rapid and thorough bleeding. The bleeding process is closely timed and monitored using sensors and timers to maximize the efficiency of blood removal, which is essential not only for meat appearance and shelf life, but also for meeting food safety regulations. Following exsanguination, the birds proceed through a high-capacity scalding tank filled with water heated to approximately 60 degrees Celsius. This stage loosens the feathers by relaxing the collagen in the feather follicles. The duration and temperature are controlled to a fine margin to ensure that the skin is neither overcooked nor damaged. After scalding, the birds are transferred into rotary feather pluckers, drum-shaped machines lined with soft rubber fingers that rotate at high speeds. These fingers remove feathers through a gentle abrasive action. Any residual feathers, particularly around the wings and tail, are removed by additional targeted plucking devices or hand finishing stations, depending on the processing line speed and factory setup. The next step is evisceration, a highly mechanized process involving robotic arms and vision-guided machinery. The system first makes a precise incision along the abdominal cavity before extracting the internal organs. This includes the heart, liver, gizzard, and intestines, which are separated into byproduct streams for different uses or disposal. Each carcass is inspected by high-speed cameras equipped with AI-powered image recognition software to detect any abnormalities such as bruising, discoloration, or contamination. Chickens that fail this inspection are automatically diverted from the production line for further examination or removal. This real-time quality assurance technology helps maintain a consistent and safe supply of chicken for further processing. Now it's time to move on to the chilling process, which is absolutely vital for halting bacterial growth and ensuring a clean transition from slaughter to further cutting and seasoning. KFC factories typically use an immersion chilling method, where eviscerated chickens are conveyed through long stainless steel tanks filled with chlorinated cold water, maintained at around 0 to 4 degrees Celsius. The flow of water is designed in a countercurrent pattern, meaning the cleanest water contacts the most recently added chickens, ensuring optimal hygiene. This step rapidly reduces the internal temperature of the chicken from roughly 40 degrees Celsius to below 4 degrees within an hour, thereby locking in freshness and significantly extending the shelf life of the meat. After chilling, the carcasses proceed to the cutting and portioning stage. This part of the process is perhaps one of the most intricate in the factory. Specialized rotary cutting machines equipped with lasers and 3D scanners assess the size and density of each chicken in real time. Based on this data, programmable robotic blades segment the carcasses into uniform cuts: legs, thighs, wings, breasts, and keels. Each piece is sized to match strict dimensional and weight criteria, which are crucial for ensuring consistent cooking times and presentation across all KFC restaurants worldwide. The system is calibrated to yield the optimal number of each type of piece from every bird, reducing waste and maximizing efficiency. If a cut doesn't meet the precise size range, it is automatically redirected for use in alternative products like tenders or popcorn chicken. The next phase focuses on marination, a process that introduces moisture, flavor, and functional ingredients into the chicken to enhance both taste and texture. Once portioned, the chicken pieces are loaded into massive stainless steel tumblers, each capable of holding hundreds of kilograms of product. Inside the tumbler, a proprietary liquid marinade blend is introduced. While the exact formulation is a closely guarded secret, the marinade typically includes salt, phosphate-based tenderizers, flavoring agents, and sometimes buttermilk solids to create the tender, juicy interior that KFC is known for. The tumbling action lasts anywhere from 15 to 30 minutes, depending on the batch size and desired intensity. And the drum rotates on multiple axes to ensure that every surface of every piece of chicken is exposed to the marinade. This mechanical agitation also helps the meat fibers absorb the liquid more thoroughly, contributing to the product's juiciness even after high temperature frying. But up next comes the breading stage, which is arguably the most iconic part of KFC's production process. After marination, the chicken is gently drained and transferred to the breading stations, where each piece is coated in the proprietary blend of flour and seasoning known famously as the 11 herbs and spices. To replicate the hand-breaded quality that KFC is known for, even at industrial scale, specialized breading drums are used. These drums simulate the hand-tossing action by gently rolling the chicken pieces in the seasoned flour, while pneumatic paddles and vibration systems ensure that every crevice is fully coated. At this point, moisture content is carefully controlled to ensure adhesion without creating clumps or overly moist surfaces, which would ruin the crispy texture during frying. Once breaded, the chicken moves immediately to the par frying or pre-frying stage. This step is critical for setting the breading so it doesn't fall off during full cooking at the restaurant. The breaded pieces are passed through continuous fryers filled with hot oil maintained at temperatures between 170 to 180 degrees Celsius. In this stage, the chicken is fried for a short duration, usually 90 to 120 seconds, just enough to solidify the coating and begin the Maillard reaction, which is responsible for the development of flavor and the golden color. The oil used in this step is filtered and refreshed continuously using an inline oil management system that maintains optimal frying conditions and ensures that the final product is never tainted by burnt residues or off flavors. The partially cooked chicken is then lifted out of the fryer via a conveyor system and deposited onto a draining belt that uses both gravity and air jets to remove excess oil. Now, it's time to transition to the flash freezing process. This is where partially cooked chicken is rapidly frozen to lock in all the flavors, textures, and moisture absorbed during marination and breading. Each piece is conveyed into a spiral freezer or impingement freezer, both of which use sub-zero air blasts or liquid nitrogen vapor to drop the temperature of the chicken from over 60 degrees Celsius to below minus 18 degrees in under 10 minutes. Rapid freezing is crucial to prevent the formation of large ice crystals, which can damage the cellular structure of the meat and result in dryness or texture loss after final cooking. During this process, each piece is also individually quick frozen, which prevents clumping and allows for precise portioning when packaging. The next step in the factory process is the automated packaging of the individually quick frozen, par-fried chicken pieces, a phase that combines high-speed precision machinery with meticulous control over product integrity. Once the chicken emerges from the spiral or impingement freezer, each piece is conveyed to a sophisticated vision inspection system that performs a final quality assurance check. High-resolution cameras and laser scanners examine each piece for uniform breading coverage, appropriate size, and the absence of any structural defects like broken bones or irregular shapes. Pieces that fail this inspection are removed from the line using targeted air jets and routed for rework or disposal, depending on factory protocol. Once the pieces pass inspection, they are conveyed into a portioning station where intelligent weighing and sorting systems group them into standardized sets that align with KFC's iconic bucket meal configurations. These could be 8-piece, 12-piece, or 16-piece configurations, depending on the regional product lineup. Multi-head weighing machines calculate the total weight and count of each portion, ensuring that every pack not only meets visual and compositional standards, but also falls within a narrowly defined weight range for inventory accuracy and consistent customer experience. These grouping systems operate at incredibly high speeds, hundreds of portions per minute, with tolerances as tight as +1 gram. Each portion of chicken pieces is then dropped into a form-fill-seal machine or into pre-formed plastic pouches, depending on the final packaging format. The form-fill-seal machines shape a plastic film into a bag, load it with chicken, flush it with a nitrogen-rich gas to minimize oxygen, and heat seal it in a continuous, uninterrupted process. Modified atmosphere packaging is used here to extend shelf life while preventing freezer burn or flavor degradation. The gas blend, often a mix of nitrogen and carbon dioxide, inhibits microbial growth and oxidation without adding any chemicals or preservatives. After sealing, the packages are labeled with all necessary tracking and compliance information. High-speed thermal transfer printers apply labels that contain lot numbers, plant codes, production timestamps, and freeze dates. These labels also include data matrix barcodes or QR codes used for traceability, allowing KFC's central quality control teams to trace every package back to its exact farm, batch, and processing line in the event of a recall or audit. Automated verification systems scan each label for accuracy and readability. Any incorrectly labeled packages are automatically rejected from the line and placed in a designated review bin for manual inspection. Now it's time to move on to case packing, where multiple individually sealed packs of chicken are grouped into corrugated cardboard boxes, each built to withstand long-distance cold chain transportation. Robotic arms equipped with vacuum suction grippers pick and place the sealed bags into the boxes with extreme precision, ensuring that space is maximized while maintaining the integrity of the chicken. Each case typically holds a specific number of meals or bucket configurations and is marked with a unique identifier. Once filled, the boxes are sealed using automated taping machines and pass through weight verification stations to ensure each box matches the expected load. Once packed, these boxes are stacked onto pallets using robotic palletizers. These robots follow pre-programmed stacking patterns that balance weight and maximize vertical space without compromising stability. Slip sheets and corner boards are often inserted between layers to protect the boxes during transit. Each completed pallet is then shrink-wrapped using a rotary arm or turntable stretch wrapper, which encases the entire stack in several layers of industrial plastic film to secure the load for transportation. A final barcode label is applied to each pallet, integrating it into the warehouse management system, which tracks every movement of inventory from production to dispatch. Next comes the crucial cold storage phase. The finished pallets are transferred via automated guided vehicles or high-speed conveyor systems into a massive cold storage facility, maintained at a consistent temperature of -18 degrees Celsius or lower. These storage facilities are designed with energy efficiency and inventory management in mind, often featuring high bay racking systems and vertical lift modules that allow for dense, organized storage. Temperature and humidity are monitored continuously by sensors linked to a centralized control room, where technicians receive alerts if any deviations occur. These warehouses are often equipped with backup generators and emergency protocols to ensure uninterrupted refrigeration in the event of power failures. After sufficient time in cold storage, which may range from a few days to several weeks depending on demand, the frozen chicken pallets are scheduled for distribution. The dispatch process begins with a pick and pack phase, where orders from various KFC regional hubs or franchise warehouses are collated. Advanced logistics software optimizes which pallets to pull based on freshness, production date, and delivery location. Selected pallets are loaded onto refrigerated trailers that maintain a controlled environment throughout the entire journey. These trucks use insulated walls and powerful refrigeration units that can be monitored remotely to ensure temperature compliance from factory to franchise. As these trucks transport the frozen chicken to regional KFC distribution centers or directly to individual restaurants, the cold chain is never broken. The receiving locations are equipped with cold storage facilities of their own, ensuring the chicken remains at safe temperatures until it's needed. At this stage, each restaurant receives a specific allocation based on forecasted customer demand, which is calculated using advanced demand planning software linked to point-of-sale data and regional market trends. The chicken remains sealed until it's ready to be used in the restaurant's kitchen, where the final stages of cooking take place. But now it's time to dive into the heart of the KFC restaurant kitchen, where the transformation from pre-cooked frozen chicken into the hot, crispy, golden brown pieces we all recognize occurs. After thawing in temperature-controlled refrigeration units for a specific number of hours, typically overnight, the chicken is brought to the breading station. Though the chicken was par-fried and breaded at the factory, a second layer of fresh breading is applied in-store to create the distinctive double crunch texture KFC is famous for. This is where the Colonel's proprietary 11 herbs and spices come into play. Each restaurant receives sealed tubs of this secret seasoning blend, pre-measured and tamper-proof. The thawed chicken pieces are first dipped into a cold, seasoned egg wash or a specialized batter mix, depending on the region. Then, they are placed into large breading bins containing the flour and spice mixture. Trained team members follow a specific press and fold technique, which involves pressing the flour onto the surface of the chicken and folding it multiple times to ensure full adhesion and the formation of the characteristic craggy, crispy coating. Each piece is then gently shaken to remove excess breading and laid out on wire racks to rest before frying. This resting period is short but essential. It allows the coating to set and adhere to the surface of the meat, reducing slippage during frying. Next, the chicken is placed into large open fryers filled with high-stability frying oil, often a soybean or canola blend, optimized for high temperatures and neutral taste. The fryers are preheated to exact temperatures, typically around 170 to 180 degrees Celsius, and the chicken is cooked under pressure for a controlled duration. KFC's use of pressure fryers is a distinctive element of its cooking process. The pressure cooking not only reduces cooking time, but also seals in moisture, ensuring the chicken remains juicy while achieving a perfectly crispy exterior. Sensors inside the fryer monitor oil temperature, pressure levels, and cooking duration down to the second. Once the timer signals completion, the fryer basket lifts automatically, and the cooked chicken is removed using heat-safe tools to ensure safety and hygiene. After frying, the chicken is transferred to heated holding cabinets that maintain a precise internal temperature, typically around 60 to 65 degrees Celsius, for a limited time, usually no longer than 90 minutes, to ensure optimal freshness and food safety. These cabinets are fitted with internal timers and alert systems to prompt kitchen staff when a batch is nearing the end of its holding time. Any product not sold within this window is discarded according to food safety protocols to maintain KFC standards. Now that the chicken is hot, crisp, and ready, it's portioned into the familiar red and white striped buckets. Each bucket is made from food-grade, grease-resistant cardboard, printed with high-resolution branding that remains vibrant, even under heat and oil exposure. The buckets are assembled on-site from flat-pack form using pop and lock mechanisms and lined with waxed paper liners. The kitchen crew follows strict guidelines when arranging the pieces inside each bucket, ensuring an appealing visual mix of drums, thighs, wings, and breasts. The buckets are then sealed with fitted plastic or cardboard lids to retain heat and are either handed to walk-in customers or packed into thermal delivery bags for transport. The final stretch of the production process involves a complex web of quality assurance protocols, food safety audits, sustainability initiatives, and continual technological improvements, all of which are critical to ensuring that every KFC fried chicken bucket, whether purchased in Tokyo, New York, or Johannesburg, meets the same high standard of taste, appearance, and food safety. These behind-the-scenes systems may not be visible to the end consumer, but they represent the foundation of KFC's global manufacturing and supply chain model. One of the most rigorous systems in place is the Hazard Analysis and Critical Control Points, or HACCP, framework. This is applied across all phases of the production lifecycle, from live animal handling at the poultry farms to final packaging at the restaurant level. Every critical control point is identified, monitored, and logged digitally. For example, in the chilling process, sensors verify that the internal temperature of chicken pieces drops to below 4 degrees Celsius within a very specific time frame. If any batch fails to meet that requirement, the system will automatically flag the anomaly, prevent further processing, and isolate the affected lot until a manual inspection is completed. These digital controls are complemented by human oversight. Trained quality control technicians regularly inspect samples at random, visually assessing breeding adhesion, meat color, texture, and aroma. At the plant level, sanitation is treated as a mission-critical activity. Every line, blade, and conveyor is cleaned on a strict schedule using a validated multi-step process that includes rinsing, application of food-grade alkaline and acidic detergents, hot water sanitizing, and ATP testing to detect any microbial residues. Cleaning in place systems are used in closed-loop systems like marinade blenders and oil filtration units, ensuring deep sanitation without the need for dismantling complex machinery. Swabs are taken from surfaces and air samples collected to detect airborne pathogens, all analyzed in on-site microbiological labs. If even a trace of Listeria, Salmonella, or E. coli is detected, entire zones of the plant are shut down and sanitized before production can resume. In parallel to these food safety systems, sensory panels and culinary scientists at centralized R&D hubs conduct organoleptic tests to ensure product consistency. These tests assess everything from the crunch of the breading to the juiciness of the meat and the aroma released when the bucket is first opened. Chicken from multiple plants is cooked and compared side by side in blind taste tests to identify deviations in flavor or texture. If a factory's output strays from the baseline profile, its formulations and techniques are reviewed. In some cases, regional adaptations are permitted. For instance, a slightly spicier breading formula in Southeast Asia, or a less salty blend in Scandinavian markets. But these must be approved through corporate sensory panels and extensive pilot runs. Now it's time to take a look at how traceability and supply chain visibility are achieved at scale. Every piece of chicken can be traced through a blockchain-based system that logs data from farm to fryer. RFID tags and barcode labels track each pallet, batch, and case throughout its journey. When a truck departs a cold storage warehouse, its GPS location is monitored in real time, and its refrigeration status is transmitted back to the operations center every 5 minutes. If a delivery truck's temperature rises above the acceptable range for more than 10 minutes, alerts are sent automatically, and corrective actions are triggered, either rerouting to a nearby cold facility or discarding the load, depending on the severity of the excursion. Once the product reaches the restaurant, the store-level staff become the final link in the quality chain. Every team member is trained not just in food preparation, but in safe handling and equipment calibration. They measure oil temperatures with infrared thermometers before every cooking cycle, check holding cabinet thermostats each hour, and perform timed inventory rotations to prevent expired stock from being used. Any discrepancies are flagged in a digital checklist that is reviewed daily by shift supervisors and weekly by regional managers. Corporate auditors also perform unannounced inspections using checklists derived from international food safety certifications such as ISO 22000 and BRC Global Standards. But up next is a growing area of emphasis for KFC's manufacturing process: sustainability. As environmental concerns increasingly shape consumer expectations and regulatory policy, KFC and its supply chain partners have invested heavily in reducing their environmental impact without compromising efficiency or food safety. For instance, many factories now operate on hybrid energy models that integrate solar or wind power into the grid supply. Heat exchangers capture and recycle waste heat from fryers and ovens to preheat water for cleaning cycles. Water treatment plants have been installed adjacent to major facilities to purify and reuse water from scalding tanks and chilling baths, thereby reducing freshwater consumption by up to 60%. Waste management is another cornerstone of sustainable operations. Offcuts, bones, and organ meats removed during the evisceration process are rendered into protein meal for use in animal feed or fertilizer. Oil used during the par-frying phase is filtered multiple times and eventually recycled through third-party processes into biodiesel or industrial lubricants. Even the breading flour that falls off during coating is collected, sifted, and reused within the same batch cycle if it remains uncontaminated thanks to high-speed sifters and air classification systems. Packaging materials are continuously redesigned to reduce plastic use, and many regional markets have adopted compostable or recyclable buckets made from sugarcane fiber or recycled cardboard. Now let's touch on automation and the future of food manufacturing. KFC's supply chain continues to push the boundaries of factory automation. Smart robotics now handle everything from chicken loading and cutting to box folding and pallet stacking. Machine learning algorithms analyze yield patterns, worker performance, and maintenance schedules to optimize output while minimizing downtime. Vision systems are paired with artificial intelligence to assess product quality in real time, not just based on weight and shape, but also by identifying anomalies invisible to the human eye, such as microfractures or uneven breading density. One of the most promising developments is the integration of digital twins, virtual replicas of entire production lines that allow engineers to test modifications in real time before applying them in physical factories. If a new breeding formula is under development, it can be modeled digitally to predict how it will behave under tumbling, par-frying, and freezing conditions. These simulations save weeks of trial and error testing and reduce waste. Some facilities even employ predictive maintenance systems powered by sensors embedded in critical equipment. These sensors monitor vibration, temperature, and pressure, allowing for preemptive repairs before machinery fails, ensuring smooth operations and uninterrupted chicken production. KFC has also begun exploring vertical integration of its logistics chain. In some regions, specially designed micro-factories are situated closer to major urban centers, reducing transit time and carbon emissions. These micro-factories handle final stage breading and par-frying, enabling fresher product delivery and enhanced responsiveness to demand fluctuations. Combined with real-time sales analytics from thousands of KFC restaurants, these decentralized production nodes can respond dynamically, ramping up or down based on foot traffic, promotions, or seasonality. The manufacturing of Pringles is an intricate process that combines food science, precise engineering, and large-scale automation to produce the uniform, crisp, and stackable potato chips recognized worldwide. Unlike traditional potato chips, which are sliced from whole potatoes and fried, Pringles are created from a specially formulated dough made primarily of dehydrated potato flakes, starches, and seasonings. The process of making Pringles in a factory involves several key stages, each meticulously designed to ensure the final product meets strict quality standards. It all begins with selecting the right raw ingredients, primarily potatoes, which serve as the foundation of the chips. However, not just any potatoes will do. Pringles require specific varieties with the right starch content to achieve the desired texture. High starch potatoes are preferred because they contribute to the crispness of the final chip and help bind the dough together during production. Once the right potatoes are sourced, they are transported in bulk to the factory, where they undergo an initial round of inspection. Before entering the processing phase, the potatoes are stored in climate-controlled environments to maintain their quality. Even small variations in temperature and humidity can affect their starch content, which in turn impacts the final texture of the chip. Workers constantly monitor these storage conditions to ensure that the potatoes remain in an optimal state before processing. When ready for use, the potatoes are moved to the preparation area, where they go through a rigorous washing process. Large industrial washers, equipped with rotating brushes and high-pressure water jets, remove dirt, debris, and any residual pesticides from the potato skins. This step is crucial, as any impurities at this stage could compromise the quality of the final product. The washing process is thorough, ensuring that only the cleanest potatoes make it to the next stage. Once cleaned, the potatoes are sent through a peeling machine, which uses either steam or mechanical abrasion to remove the skins efficiently. Steam peeling is a common method in large-scale food production, as it allows for quick and uniform removal of the skin with minimal waste. The peeled potatoes are then conveyed to slicing machines, but unlike conventional potato chips, where these slices would be fried, the goal here is to break them down into a form that can be processed into a dough. To achieve this, the sliced potatoes are sent through a pre-cooking stage, where they are partially heated to help break down their cellular structure. This step makes it easier to remove moisture later in the process. The pre-cooked potato slices are then transferred to large industrial dryers, as possible is used efficiently. The ability to reuse excess dough is one of the advantages of making Pringles from a formulated dough rather than whole potato slices. At this point, the chips are still in their raw, unbaked form. They have been cut into shape, but they are not yet crispy. To achieve their signature texture, they must go through the next phase of the manufacturing process, where they will be carefully molded and cooked. This is where Pringles truly begin to take on their distinctive identity. Before they can be cooked, the raw chips must be shaped into their famous curved form. This is done using a specialized conveyor system that gently places each chip into a custom mold. These molds are designed to hold the chips in a precise curve, known as a hyperbolic paraboloid, which is what gives Pringles their unique stacking ability. The shape is not just for aesthetics. It also helps distribute weight evenly when the chips are stacked in their can, preventing them from breaking easily. Once placed in the molds, the chips are conveyed toward the cooking stage, where they will be exposed to controlled heat and oil. This step is critical in achieving the crispy, golden brown texture that Pringles are known for. However, unlike traditional potato chips, which are deep fried in vats of hot oil, Pringles are cooked in a specialized method that ensures even frying while maintaining their precise shape. At this point, the chips are not yet fully cooked, nor have they been seasoned. The next phase will involve exposing them to heat and oil, followed by a careful seasoning process that gives each chip its final flavor. But before that happens, factory workers and automated quality control systems continuously monitor the process to ensure that each chip is perfectly shaped and free of defects. With the raw dough pieces now cut into their precise, uniform shapes and carefully placed into their curved molds, they are ready to undergo the critical cooking process. This step is what transforms the soft, pliable dough into the crisp, golden brown chips that Pringles are known for. Unlike traditional potato chips that are submerged in deep vats of hot oil and fried freely, Pringles undergo a much more controlled cooking method to maintain their exact shape and texture. The chips, still nestled in their curved molds, travel along a continuous conveyor belt into an industrial fryer. This fryer is designed to ensure that each chip is cooked at an exact temperature for a precise amount of time. The temperature inside the fryer is meticulously controlled, typically ranging between 300 degrees Fahrenheit and 375 degrees Fahrenheit, depending on the specific requirements of the batch being produced. The goal is to remove moisture from the chips without overcooking them, achieving the perfect crunch while preserving the uniform shape. The frying process takes only a matter of seconds, but within that short time, several crucial chemical reactions occur. The high heat causes the remaining water content inside the dough to rapidly evaporate, creating tiny air pockets that give Pringles their distinctive lightness. At the same time, the starches and sugars in the dough undergo the Maillard reaction, a chemical process that causes browning and enhances the chip's flavor by developing rich, slightly nutty, and toasted notes. Because the chips are fried in a controlled environment while sitting inside their molds, they do not curl or warp the way traditional potato chips do. Instead, they maintain their signature hyperbolic paraboloid shape, which is key to their ability to be stacked efficiently without breaking. To ensure even cooking, the oil circulates through the fryer using a sophisticated system that maintains uniform heat distribution, preventing any chip from becoming overcooked or undercooked. Once the chips have been fried to perfection, they must be quickly removed from the hot oil to prevent excessive absorption of fat, which could compromise their texture and make them overly greasy. The chips exit the fryer onto a draining conveyor, where excess oil is gently shaken off. A series of air jets then blow away any remaining oil droplets, ensuring that each chip has the right balance of crispness without being overly oily. The amount of oil that remains in the final product is carefully monitored, as even a small deviation in fat content could alter the texture and mouthfeel of the chips. After the excess oil is removed, the chips continue along the conveyor system into a specialized drying chamber. This drying stage serves a dual purpose. It helps eliminate any remaining moisture to extend the shelf life of the chips and ensures that they retain their crisp texture. If any residual moisture remains, it could lead to sogginess or even microbial growth, which would compromise the quality of the product. The drying chamber operates using a controlled flow of warm air, which gently removes any lingering humidity without exposing the chips to excessive heat. This is a crucial step because over-drying could make the chips too brittle, leading to breakage before they even reach the packaging stage. The process must strike a balance between removing moisture while preserving the ideal crunch. Now that the chips have been properly fried and dried, they still lack one essential component: flavor. While the dough contains some base seasonings, such as salt, the majority of Pringles' signature flavors are added after cooking. At this point, the chips are still relatively plain, resembling lightly salted potato crisps. To give them their final taste, they must go through the seasoning process. The chips enter a large rotating drum, which is a key part of the flavoring system. This drum functions much like a giant tumbler, gently tossing the chips to ensure that each one is evenly coated with seasoning. However, before the seasoning can be applied, the chips must be lightly misted with a fine spray of oil. This thin coating of oil acts as an adhesive, allowing the seasoning to stick uniformly to each chip without clumping. Once the oil mist has been applied, the chips move further into the drum, where a precise amount of seasoning powder is dispensed. This powder is a proprietary blend of dehydrated spices, artificial and natural flavors, and other ingredients that create the distinct taste of each Pringles variety. Whether it's the classic original, sour cream and onion, barbecue, or any of the many other flavors available around the world, each seasoning mix is carefully crafted to deliver a consistent and recognizable taste. The rotation of the drum ensures that the seasoning is distributed evenly across all chips, preventing any one chip from receiving too much or too little flavor. This is crucial because even slight inconsistencies in seasoning distribution can affect the overall eating experience. Too much seasoning on one chip could make it overpowering, while too little could make it bland. The factory's precision-engineered system ensures that every chip in a can has the same delicious taste. To confirm that the seasoning has been applied correctly, automated sensors monitor the amount of seasoning powder dispensed and the overall coating level. These sensors use advanced optical and weight measurement technologies to detect any irregularities in the seasoning process. If an issue is detected, such as an uneven application or a deviation from the standard amount of seasoning, the system can automatically adjust to correct the problem in real time. Now fully seasoned, the chips continue their journey toward the final stages of production. At this point, they must be carefully handled to prevent breakage before they are packaged. Despite their sturdy design, Pringles are still delicate enough to crack if handled too roughly, so the conveyor system is designed to gently transport them through the factory. Before reaching the packaging area, the chips pass through another quality control checkpoint. High-speed cameras and sensors inspect each chip to ensure that they meet the brand's strict standards. Any chips that are overly browned, misshapen, or broken are automatically removed from the line. These rejected chips do not go to waste. They are often ground down and repurposed as part of the raw ingredient mixture for new batches, minimizing food waste in the production process. Now, with their perfect shape, crisp texture, and flavorful coating, the chips are ready for packaging. However, the packaging process itself is an essential part of what makes Pringles so unique. Unlike traditional potato chips, which are packed into bags that allow for some degree of breakage, Pringles are carefully stacked inside rigid cylindrical cans. This design ensures that they remain intact from the moment they leave the factory to the time they are opened by consumers. As the chips approach the packaging area, specialized machines align them into precise stacks. These machines use gentle vibrations and suction mechanisms to ensure that each stack is perfectly arranged before being inserted into the canisters. The stacking process is incredibly precise. Any misalignment could cause the chips to break during transportation. At this point, the Pringles are nearly ready to be sealed and sent out for distribution, but there are still a few final steps left to complete before they can reach store shelves. The packaging must ensure freshness, provide product protection, and meet branding and labeling requirements. In the next stage, the stacked chips will be inserted into cans, sealed for freshness, and prepared for shipment. With the freshly seasoned chips perfectly stacked and aligned, the Pringles are now ready for the crucial packaging stage. This process is just as important as the manufacturing and cooking steps, as it ensures that the chips remain intact and fresh until they reach consumers. Unlike traditional potato chips, which are packed loosely in bags that allow for some level of breakage, Pringles are carefully placed into rigid cylindrical cans, a signature feature that sets them apart from other snack foods. The packaging process begins with the automatic loading of the Pringles stacks into their respective canisters. These canisters, made from a combination of cardboard and aluminum lining, are designed to provide structural support, protecting the delicate chips from breaking during transport. The cans arrive at the packaging station in a flattened state and are quickly formed into their cylindrical shape by specialized machinery. The inner lining of the cans is coated with a food-safe aluminum layer, which helps to preserve freshness by preventing exposure to moisture and air. Once the cans are fully formed, they are transported to the filling station, where the Pringles stacks are precisely inserted into them. This process requires extreme precision, as any misalignment could cause the chips to shift or break. A combination of gentle vibrations and suction mechanisms ensures that the stacks remain stable as they are guided into the canisters. If even a single chip in the stack is out of place, the entire batch may be rejected to maintain quality standards. As the filled cans move along the conveyor, they reach the sealing station, where a thin foil seal is applied to the top of each canister. This foil seal serves multiple purposes. It locks in freshness, prevents air from entering, and ensures that the chips remain crisp for an extended period. The application of the seal is a highly controlled process that uses a combination of heat and pressure to create an airtight bond between the foil and the can's rim. Automated sensors continuously monitor the sealing process, detecting any imperfections or leaks. If a faulty seal is identified, the can is removed from the production line and either reprocessed or discarded. After the foil seal is in place, a plastic lid is applied to the top of the can. This lid serves as a secondary protective barrier and allows consumers to reseal the container after opening. The lids are typically made from lightweight but durable plastic that ensures a secure fit while remaining easy to remove. Before being placed onto the cans, the lids are inspected for defects, such as warping or cracks, which could compromise the product's freshness. With the Pringles cans now fully assembled and sealed, they move toward the labeling and branding station. Here, pre-printed labels featuring the Pringles logo, flavor designation, and nutritional information are carefully wrapped around each canister. These labels are made from high-quality materials that are resistant to moisture and tearing, ensuring that they remain intact throughout the product's journey from the factory to store shelves. A combination of heat and adhesive is used to secure the labels in place, ensuring a smooth, wrinkle-free application. Once labeled, the finished cans undergo another round of quality control checks. Automated cameras and sensors scan each can to verify that the labels are correctly applied and free of defects. Any cans with misaligned or damaged labels are removed from the line and either relabeled or discarded. Additionally, random samples from each batch are taken for more detailed inspections, where factory workers check for overall product integrity, including stack alignment, sealing effectiveness, and crispness. After passing the final quality control checks, the Pringles cans are grouped together for bulk packaging. This step involves placing multiple cans into larger cardboard cartons or shrink-wrapped bundles, which make transportation and stocking more efficient. In some cases, local flavors are developed exclusively for specific markets, adding an element of regional customization. With the fully sealed and labeled Pringles cans ready for shipment, the final step in the manufacturing process involves distribution and logistics. Once the pallets of Pringles leave the factory, they are sent to distribution centers where they are sorted based on destination. From here, they are shipped to retail locations around the world, including supermarkets, convenience stores, vending machines, and online retailers. One of the key advantages of Pringles' packaging is its durability. Unlike traditional potato chips that are shipped in large bags, prone to air compression and breakage, Pringles' rigid canisters allow for efficient stacking and transport without excessive damage. This means fewer chips are wasted due to breakage during shipping, making the product more cost-effective and reducing food waste. At the retail level, Pringles cans are often displayed in neat, vertical arrangements on shelves, taking advantage of their cylindrical shape. This design not only protects the chips, but also maximizes shelf space compared to bulky chip bags. Supermarkets and convenience stores follow specific stocking guidelines to ensure that Pringles cans remain undamaged and easily accessible to customers. Once purchased, consumers benefit from the resealable can, which keeps the chips fresh longer than traditional bags. Unlike conventional chip bags that often allow air to seep in after opening, leading to stale chips, Pringles' airtight design helps maintain their signature crunch over multiple servings. This has been a significant selling point for the brand and one of the reasons for its continued popularity. Beyond the production process, the Pringles brand continues to evolve. The company regularly develops new flavors, incorporating regional tastes and limited edition releases to cater to different markets. Flavors such as wasabi, pizza, and even dessert-inspired varieties have been introduced over the years, keeping the brand relevant and exciting for consumers. In recent years, sustainability has become a growing concern, leading to efforts to improve the recyclability of Pringles packaging. While the multi-material composition of the can presents challenges for recycling, Pringles manufacturers are exploring alternative packaging solutions that reduce environmental impact while maintaining product integrity. As technology advances, the future of Pringles manufacturing may include even greater automation, improved energy efficiency, and smarter quality control systems. Artificial intelligence and machine learning could further refine production, ensuring even higher consistency in shape, flavor, and texture. Additionally, new ingredients and production techniques could be developed to create healthier or more sustainable variations of Pringles. The journey of a Lay's potato chip begins long before it reaches the factory. It starts in carefully selected farms, where high-quality potatoes are cultivated under strict agricultural standards. Lay's manufacturers work closely with farmers to ensure that only the best potato varieties are used, focusing on those with the right balance of starch and moisture. This is crucial because the composition of the potato determines how well it crisps during frying and how it absorbs seasoning. The selected varieties are chosen for their ability to produce a light, crunchy texture while maintaining the signature taste that has made Lay's a household name. The potatoes are grown in rich, fertile soil, monitored throughout the growing season to ensure optimal size, shape, and starch content. Farmers pay close attention to irrigation, pest control, and harvesting schedules to meet the brand's high standards. When the potatoes reach the perfect stage of maturity, they are harvested using specialized machinery designed to minimize bruising and damage. The harvested potatoes are loaded into large trucks and transported to Lay's production facilities, where the real transformation begins. Upon arrival at the factory, the potatoes undergo an initial inspection to check for quality, size, and any visible defects. Automated sorting machines and human inspectors work together to identify and remove any potatoes that do not meet the necessary standards. The goal is to ensure that every potato entering the production line will contribute to the consistent, high-quality chips that consumers expect. The selected potatoes are then stored in climate-controlled environments to maintain their freshness until they are ready to be processed. Before they can be turned into chips, the potatoes must be thoroughly cleaned. They pass through high-powered washing systems that remove dirt, pesticides, and any residual soil from the harvesting process. This step is crucial, as even tiny impurities could affect the taste and texture of the final product. The cleaning process uses jets of water and rotating brushes that scrub the potatoes without damaging their structure. After washing, the potatoes move along a conveyor belt toward the peeling station. Peeling is an essential step in ensuring a smooth and uniform surface for slicing. Large industrial peeling machines use abrasion or steam to remove the skin efficiently while preserving as much of the potato as possible. The peeling method used depends on the specific facility, but both techniques are designed to be fast and effective, ensuring that the potatoes retain their natural integrity. Any residual skin is removed by high-pressure water sprays before the potatoes move to the next phase of production. With the potatoes now clean and peeled, they are ready for slicing. The slicing process is one of the most critical steps in determining the texture and crispness of the final chip. The potatoes are fed into high-speed rotary slicers equipped with precision-engineered blades. These blades cut the potatoes into uniformly thin slices, ensuring that each chip cooks evenly. The thickness of the slices varies depending on the type of Lay's chip being produced, whether it's classic, wavy, or kettle cooked. The precision of the slicing process is carefully monitored, as even slight variations in thickness can affect the frying process and overall quality. Once sliced, the potato pieces undergo another quick rinse to remove excess surface starch. This helps prevent the chips from sticking together during frying and contributes to the signature crisp texture. The slices then move through an automated dewatering system, where excess moisture is removed before they enter the frying stage. Proper moisture removal of the entire process. Quality control. Lay's has built its reputation on delivering chips that are consistent in taste, texture, and appearance. And this is only possible through rigorous inspections at multiple points along the manufacturing process. Each chip must meet exacting standards before it is deemed fit for packaging, so quality control systems are an integral part of the factory's operation. The first stage of quality control involves high-speed cameras and sensors that scan the chips as they pass along the conveyor belt. These cameras are equipped with advanced imaging technology that detects any chips that are misshapen, burnt, undercooked, or broken. If a chip does not meet the specified criteria, it is automatically removed from the production line using precision air jets that quickly and efficiently separate defective chips from the rest. This ensures that only chips of uniform shape, size, and color continue on their journey. Alongside the automated quality control systems, trained inspectors conduct manual checks at various points in the production process. These specialists sample chips from every batch, testing for crunchiness, oil content, seasoning distribution, and overall flavor consistency. Taste tests are regularly performed to ensure that every chip has the signature Lay's flavor profile. If an inconsistency is detected, adjustments can be made immediately to the frying temperature, seasoning application, or oil levels to correct the issue before it affects a large quantity of product. While the chips are still warm, they move along the conveyor belt toward the cooling system. The cooling stage is essential because the chips must be brought down to a stable temperature before they can be packaged. If the chips were packed while still warm, condensation could form inside the packaging, leading to sogginess or loss of crispness. To prevent this, the chips pass through cooling tunnels where controlled air circulation gradually reduces their temperature. This step ensures that when the chips reach the packaging stage, they maintain their light, crunchy texture. Once cooled, the chips approach another crucial phase, sorting and weighing. The production line is equipped with highly sensitive scales that measure precise portions of chips. These automated weighing systems are programmed to dispense an exact amount of chips into each bag, ensuring consistency across all packages. The portioning must be extremely precise to meet regulatory weight standards and ensure that customers receive the correct amount of product. Any deviations in weight trigger an automatic adjustment in the dispensing system. After portioning, the chips are directed into the bagging machines, where specially designed Lay's packaging material awaits them. The bags are made from multi-layered, high-barrier film that helps protect the chips from moisture, light, and oxygen, three factors that can negatively impact their freshness and taste. The packaging is specifically designed to extend shelf life while preserving the signature crunch and flavor. As the chips drop into the open bags, a stream of nitrogen gas is injected into each bag before sealing. This process, known as nitrogen flushing, serves a crucial purpose. By replacing the oxygen inside the bag with nitrogen, the factory prevents oxidation, which can cause the chips to become stale over time. The nitrogen also helps create a cushioning effect inside the bag, preventing the chips from breaking during transportation and handling. The sealed bags are then heat sealed using precision machinery that ensures an airtight closure. Once sealed, the freshly packed bags of Lay's chips move along the conveyor to the final quality control checkpoint. Here, inspectors verify that the bags are sealed properly that they contain the correct weight and that there are no issues with the packaging material. Automated sensors scan the bags for any irregularities, such as improper sealing or printing errors on the labels. If any issues are found, the defective bags are removed from the line before they reach distribution. At this point, the bags are ready for bulk packaging. Large robotic arms carefully arrange the individual chip bags into larger cartons or cases, which are then sealed and labeled for shipment. The cases are stacked onto pallets in an optimized configuration to maximize space efficiency in shipping trucks and storage facilities. The pallets are then loaded onto trucks and transported to Lay's distribution centers, where they are sorted based on their destination. While the chips are being prepared for distribution, data is continuously being collected from the production line to track performance and efficiency. Advanced factory management systems monitor every aspect of the sent out to retail locations. Temperature and humidity levels inside the warehouses are carefully maintained to ensure that the chips do not absorb excess moisture, which could compromise their crisp texture. At this stage, automated inventory management systems help keep track of shipments, ensuring that stores receive the correct quantities and flavors based on regional demand. As the chips are shipped out to grocery stores, convenience stores, gas stations, and other retail locations, the logistics team continuously monitors their movement. The goal is to minimize the time it takes for a freshly produced bag of chips to reach the shelves, preserving the crunch and flavor that customers expect. Lay's supply chain is designed for efficiency, with trucks following optimized routes to deliver products as quickly as possible. In some cases, chips that are produced in the morning can be on store shelves by the afternoon in nearby regions. At retail locations, store employees are trained to handle Lay's chips carefully during stocking. The lightweight nature of the packaging means that the bags can be susceptible to compression if not stacked correctly. Retailers follow strict guidelines to ensure that chips are displayed properly, with newer shipments placed behind older stock to maintain freshness. In vending machines, the placement of Lay's chips is also optimized to prevent excessive movement that could lead to breakage. The careful handling of the product at every stage is what ensures that customers receive whole, unbroken chips when they open a bag. The journey of Lay's chips does not stop at store shelves. Consumer feedback plays a vital role in shaping future production decisions. Lay's has dedicated teams that analyze purchasing trends, customer reviews, and market demands to determine which flavors and varieties are most popular. This data influences everything from production volume to regional flavor innovations, ensuring that Lay's continues to evolve with consumer preferences. In some cases, limited edition flavors are introduced based on feedback, with certain varieties becoming permanent offerings if they prove successful. As technology advances, Lay's continues to refine its production methods to improve efficiency, reduce waste, and enhance sustainability. One of the major challenges in large-scale snack production is minimizing the environmental impact of operations. To address this, Lay's has implemented initiatives to optimize energy usage in factories, improve water conservation during potato processing, and explore more sustainable packaging solutions. One of the key sustainability efforts involves reducing food waste during production. While some defective chips are removed during quality control, they are not simply discarded. Instead, these chips are often repurposed as animal feed or converted into biofuel, ensuring that as little as possible goes to waste. Additionally, potato scraps from the peeling and slicing process are collected and used for other food products or composting. The use of sustainable farming practices is also a priority for Lay's suppliers. Many of the farms that provide potatoes for Lay's have adopted eco-friendly techniques such as crop rotation, reduced pesticide usage, and precision irrigation to minimize water consumption. By working closely with farmers, Lay's ensures that its supply chain remains both environmentally responsible and efficient. Packaging innovation is another area of focus for Lay's as it looks for ways to make its chip bags more eco-friendly. Traditional chip packaging is made from multi-layered plastic film, which is designed to protect the chips from moisture and air exposure. However, the complex nature of this material makes it difficult to recycle. Lay's has been researching alternative packaging solutions that maintain freshness while reducing plastic waste. Some markets have already seen the introduction of biodegradable or recyclable chip bags, with further developments expected in the future. Automation and artificial intelligence are also playing an increasing role in Lay's production process. Advanced AI-driven quality control systems are being used to detect imperfections with greater accuracy than ever before. These systems can analyze thousands of chips per second, ensuring that every batch meets the highest standards. Additionally, robotic automation is improving efficiency in packaging and palletizing, allowing for faster and more precise handling of products. Beyond production, Lay's continues to engage with consumers through marketing, advertising, and promotions. The brand regularly collaborates with chefs, influencers, and food scientists to introduce new flavors and snack innovations. Limited edition seasonal flavors, cross-cultural fusion varieties, and unique textures like extra crispy or extra flavored chips keep the product line dynamic and exciting for customers. One of the most intriguing aspects of Lay's chips is how different regions have their own exclusive flavors, reflecting the local tastes and culinary preferences of different cultures. In Asia, flavors such as seaweed and spicy hot pot are popular, while in North America, barbecue and sour cream and onion remain among the best sellers. Europe has its own set of unique offerings, including flavors inspired by traditional cheeses and herbs. The ability to adapt to different markets while maintaining the core essence of Lay's chips is what has helped the brand maintain its global appeal. At its core, the production of Lay's chips is a blend of science, technology, and tradition. The balance between maintaining the classic quality that customers expect while continuously innovating is what keeps Lay's at the forefront of the snack industry. From the careful selection of potatoes to the high-speed frying process, precise seasoning application, and advanced packaging techniques, every step is optimized to ensure consistency, flavor, and crunch in every bite. The cycle of chip production never truly stops. Even as one batch is being transported to stores, another is already being prepared in the factory. The efficiency of the Lay's production process ensures that there is always a fresh supply of chips available for consumers. The combination of high-tech manufacturing, sustainability initiatives, and a deep understanding of consumer preferences keeps Lay's chips at the top of the snack food market, continuously evolving to meet the changing tastes and expectations of snack lovers around the world. The production of Cheetos begins not with cheese or seasoning, but with one humble ingredient: corn. In fact, the specific type of corn used in Cheetos manufacturing is carefully selected and processed to meet exacting technical standards before it even enters the plant. The base product of every Cheeto is degermed cornmeal, derived from a variety of field corn that is specially cultivated for its high starch content and low fat levels. This corn must produce a uniform, predictable puff when subjected to extreme heat and pressure, so its density, moisture content, and kernel hardness are closely monitored even at the agricultural stage. Farmers contracted by the manufacturer are required to meet tight tolerances in grain quality, harvesting methods, and post-harvest drying to ensure the raw corn will meet the standards for industrial puffed snack production. Once harvested and transported to the ingredient supplier, the corn undergoes an initial cleaning to remove plant debris, soil, and foreign materials. It is then taken through a degermination process, in which the outer bran layer and the germ, the oil-rich, nutrient-dense part of the corn kernel, are removed. This step is essential. While germ and bran contain healthy fats and proteins, their presence can negatively impact the expansion properties and shelf life of the final product. Germ oil can go rancid over time and interfere with the consistent puff structure that defines a Cheeto. What remains after degermination is the starchy endosperm, milled down into a fine cornmeal that becomes the building block of every puff. This cornmeal is then enriched with a blend of vitamins and minerals, including riboflavin, niacin, iron, and folic acid. The enrichment not only helps meet nutritional labeling requirements, but also contributes to uniformity in the extrusion process, as these additives influence how the mixture reacts under heat and pressure. The resulting product is a dry, golden yellow flour with a specific granulation profile tailored to the plant's extrusion parameters. Before it is used on the production line, the cornmeal is stored in temperature and humidity-controlled silos directly connected to the processing plant. These silos often hold hundreds of metric tons of product and are designed to keep the cornmeal in a stable state for extended periods. Pneumatic systems transfer the cornmeal through stainless steel pipelines to weigh hoppers on the factory floor, where batch sizes are precisely measured. Real-time inventory sensors track the flow of material and communicate with the factory's central control system to automatically replenish supply lines as needed, ensuring uninterrupted production. Now it's time for the first transformation phase, hydration and preconditioning. The cornmeal is metered into a continuous mixing system where it is blended with water or steam to raise its moisture content to a narrowly specified range, usually between 15% and 20%. This step is essential to prepare the starch molecules for gelatinization. The equipment used here is not unlike a ribbon blender or paddle mixer, which agitates the mixture thoroughly to ensure every granule of cornmeal is evenly hydrated. Water is introduced through atomizing nozzles positioned at calculated intervals along the mixer's length, and multiple moisture sensors along the pathway feed back to the PLC system to adjust water input in real time. This moist mixture, often referred to as dough, despite its loose, crumbly texture, is held briefly in a conditioning tank to allow for even moisture distribution. The temperature and residence time are carefully controlled. If the mix is too hot or too wet, it may pre-gelatinize and clog the extruder. Too dry, and it won't expand properly. During this stage, the product is slowly moved along a jacketed screw conveyor that maintains a consistent temperature and prevents clumping. Now we arrive at the heart of the production line, the extruder. Industrial Cheetos are made using a twin screw extruder, one of the most sophisticated and critical machines in the plant. The twin screw configuration allows for highly controlled processing of the corn mixture, providing better mixing, higher shear, and superior control over temperature and pressure compared to single screw models. The hydrated cornmeal is fed into the extruder barrel, where it encounters two rotating screws that convey the material forward under intense mechanical pressure. External heaters line the barrel and raise the temperature incrementally as the product moves through each zone. Inside, shear forces generated by the screws convert some of this mechanical energy into heat, further increasing the temperature of the dough. The intense conditions inside the extruder, pressure in the range of 200 to 500 psi, and temperatures from 130 degrees Celsius to 180 degrees Celsius, cause the starches in the cornmeal to gelatinize and the water to superheat. The dough undergoes plasticization, becoming a molten mass under pressure. As this molten dough reaches the end of the barrel, it is forced through a die, the precision-crafted metal plate that defines the shape of the puff. The die hole is round and small, but as the dough exits into atmospheric pressure, the superheated water in the mixture flashes into steam, causing the structure to puff and expand dramatically in a fraction of a second. This rapid expansion is responsible for the iconic airy texture of a Cheeto. Just outside the die, rotating knives spin at high speed, slicing the continuous stream of puff into uniformly sized segments. The speed of the knives determines the length of the puff, while the pressure and temperature within the extruder affect its diameter and density. But even after this high-tech transformation, the newly extruded Cheetos are far from finished. They are still pale, moist, and bland, essentially unseasoned corn puffs. The next stage is all about turning them into the crunchy, craveable snack that consumers instantly recognize. First, the extruded pieces are conveyed via vibrating trays to a frying system. Here, they're submerged in hot oil, typically corn or canola oil, at carefully controlled temperatures ranging between 160 degrees Celsius and 180 degrees Celsius. The residence time in the fryer is only about 20 to 40 seconds, but in that time, the moisture content is reduced dramatically from around 15% to under 2%. This not only creates the final crispy texture, but also deepens the color slightly, giving the snack its characteristic golden hue. The fryer itself is a marvel of engineering, equipped with multiple sensors and filtration systems. Oil turnover rates are high, meaning that fresh oil is constantly added, while spent oil is removed and filtered to maintain quality. Skimmers remove any floating particles, and oil chemistry is monitored for signs of oxidation, free fatty acid levels, and polymerization. If any readings fall outside of the strict parameters, the fryer automatically triggers corrective actions, dosing with fresh oil, increasing filtration, or even pausing the line to prevent compromised batches from continuing downstream. After exiting the fryer, the Cheetos are carried on mesh conveyors through an air cooling tunnel. High-powered fans blow ambient or conditioned air over the freshly fried snacks, bringing them to a safe handling temperature and ensuring any surface oil solidifies just slightly to help the seasoning adhere. These cooling conveyors are extended and designed with soft vibratory motion to prevent breakage, ensuring that the delicate puffs remain intact before entering the seasoning phase. Next, the Cheetos are transferred into a massive rotating flavor drum, where their bland exterior is transformed by a shower of powdered cheese blend. But before we dive into the complexities of seasoning, we'll need to explore how oil coating is applied for adhesion and how powder distribution systems are calibrated to ensure every single puff gets the perfect amount of flavoring. This next part of the production process is where precision meets sensory science, and the result is the addictively cheesy snack that has become a global favorite. Now it's time to dive into one of the most iconic and intricate stages in Cheetos manufacturing, the flavoring phase. This is where the bland, puffed, and fried corn kernels are transformed into the intensely savory, cheese-coated snacks recognized all over the world. The process of seasoning Cheetos is not merely about tossing on a bit of cheese powder. It is an engineered, tightly controlled operation that determines product consistency, taste balance, visual appeal, and even mouthfeel. Everything from the size and porosity of the puff to the electrostatic charge of the powder particles is taken into account in this phase. After exiting the cooling conveyor from the fryer, the puffs are transferred into large rotating cylindrical drums called flavor tumblers. These drums are typically positioned on a gentle incline and rotate slowly, creating a continuous cascade of puffs inside the drum that exposes every surface area of each piece as they tumble forward. This mechanical tumbling is crucial. It ensures an even coating without crushing the fragile, aerated product. Inside the drum, two key applications occur almost simultaneously. First, a fine mist of oil is sprayed onto the hot puffs. Then, a controlled stream of seasoning powder is dispensed over the tumbling mass. The oil, which is typically a neutral vegetable oil like corn or canola, plays several roles in this step. Primarily, it acts as an adhesive layer that allows the seasoning powder to stick effectively to the puff's surface. Additionally, it helps activate the flavor compounds in the powder blend, carrying volatile aroma molecules and enhancing taste perception. The oil spray system uses ultra-fine atomizing nozzles that are precisely calibrated to deliver a uniform coat without oversaturation. Too much oil, and the puffs become greasy and soggy. Too little, and the powder won't adhere properly, leading to uneven seasoning distribution and flavorless bites. The timing, angle, and rate of oil application are closely monitored and adjusted by sensors and programmable logic controllers. Real-time feedback systems measure oil usage, droplet size, and the thermal signature of the puffs to ensure that coating is optimal under varying production speeds or ambient conditions. This level of automation ensures consistency across thousands of pounds of product produced per hour. As the puffs are coated in oil, the seasoning powder is introduced using a vibratory feeder or screw conveyor system. The powder is held in a hopper mounted above the flavor drum and is dispensed through controlled openings at a fixed rate, matched to the flow of puffs. The exact dosing rate depends on the type of Cheetos being produced. Flamin' Hot varieties require slightly more powder per unit than the traditional cheese puffs due to differences in density, powder, granularity, and flavor intensity. The seasoning blend itself is a complex formulation engineered not only for taste, but also for flow characteristics, adhesion, and shelf stability. The base of the powder is often dehydrated cheddar cheese, spray-dried into a fine particle form. This is combined with whey or whey protein concentrate, maltodextrin, salt, monosodium glutamate, MSG, disodium phosphate, citric acid, and natural or artificial flavors. Each of these ingredients plays a very specific role. Maltodextrin, for example, acts as a carrier and anti-caking agent that helps the powder distribute evenly and resist clumping. Citric acid provides a tangy bite that enhances cheese flavor. MSG boosts umami and deepens savory perception. Color additives like annatto or oleoresin paprika for classic cheese, and red 40 or yellow 6 for Flamin' Hot are oil dispersible pigments that give the snack its vivid appearance without creating spotting or streaks. The particle size distribution of the powder is engineered to align with the surface texture of the puffed snack. Powder that's too coarse will fall off, and powder that's too fine will clump or create an overly dusty texture. To prevent powder fallout, electrostatic systems are sometimes used in high-speed lines. In these cases, the powder is given a minor static charge to improve its affinity for the puff surface, minimizing waste and improving adhesion. Inside the flavor tumbler, the balance of oil spray and powder distribution creates a beautiful, uniform layer of seasoning that fully coats each puff without pooling at the bottom of the drum or leaving bald spots on the product. The drum's internal design is key. Angled baffles gently lift and drop the puffs to keep them moving without subjecting them to mechanical stress. As the snacks make their way to the end of the drum, they are now visually and sensorially transformed. Bright orange, evenly coated, and bursting with aroma. Once the seasoning phase is complete, the fully flavored Cheetos are gently transitioned to the final conveyor belt systems that lead to the packaging area. Here, another series of quality control measures come into play. Inline camera systems inspect color uniformity and powder coverage using advanced image recognition algorithms. If a section of the product stream is detected to have an irregular appearance, whether due to light seasoning, overcoating, or discoloration, it is flagged and diverted from the main line for manual inspection or disposal. At this point, the Cheetos are still vulnerable to moisture pickup, oxidation, and mechanical damage, so the packaging process must move swiftly and with precision. The conveyor system delivers the finished puffs to a multi-head weigher mounted above the bagging machines. This machine uses multiple weigh hoppers to rapidly measure exact product portions, typically in the range of 28 g to 250 g per serving. depending on the bag size. These weighers use real-time load cell feedback to select the optimal combination of buckets to match the target weight, within a tolerance as tight as +no. 2G. Each pre-measured portion is released down a chute into a vertical form-fill-seal (VFFS) machine. These machines work by pulling a flat roll of pre-printed film through a collar that forms it into a tube. The bottom of the tube is heat sealed to create the first seam, the Cheetos are dropped in, and then the top is sealed and cut, simultaneously forming the bottom seal of the next bag in line. These machines can fill and seal over 100 bags per minute per lane, and multiple lanes often run in parallel for large-scale production. The film used for the packaging is multi-layered and engineered to provide barrier protection against light, oxygen, and moisture. It typically includes an outer polyester film for print quality and visual appeal, a middle layer of aluminum or metallized polypropylene for oxygen and light resistance, and an inner polyethylene layer for heat sealing and moisture resistance. As each bag is sealed, a date code, batch number, and factory identifier are printed using high-speed inkjet printers for traceability. Just after sealing, every bag passes through a series of checkpoints. Metal detectors scan for any foreign objects, vision systems verify print alignment and code readability, and weight checkers ensure compliance with regulatory standards. Non-conforming bags are automatically ejected onto a rejection conveyor, where they are set aside for manual inspection. Approved bags are then grouped and packed into cardboard shipping cartons by robotic pick-and-place systems or automated drop packers. These cartons are sealed, barcoded, and routed to the palletizing station. Here, industrial robotic arms stack the cartons onto wooden or plastic pallets using optimized patterns for stability and load balance. As each pallet is completed, it is wrapped in stretch film to secure the load and protect it from dust and humidity during storage and transportation. The palletized loads are then scanned into the plant's warehouse management system, which tracks location, batch status, and distribution destination. Some pallets are moved to ambient storage if they are designated for short-haul routes, while others are transported to climate-controlled storage areas that maintain low humidity and consistent temperatures, ensuring that the product maintains its texture and flavor until it reaches its final destination. What follows is the outbound logistics phase, where the pallets are loaded onto trucks, routed to distribution centers, and delivered to retailers. But for now, every step inside the production facility, from the moment the cornmeal is hydrated to the final bag, passing the last inspection point, has been a meticulously engineered series of chemical, mechanical, and sensory transformations. Every component of the Cheetos production line is designed not just for efficiency and speed, but to deliver a reliably indulgent experience in every bag. And it all happens in a continuous, automated, high-output environment that must maintain exacting standards of quality, cleanliness, and consistency hour after hour, shift after shift. One of the key operational pillars at this stage is environmental control. Temperature, humidity, and airflow within the production zones are tightly monitored and controlled around the clock. Cheetos, especially after frying and seasoning, are highly sensitive to ambient conditions. If the air in the seasoning or packaging area carries too much humidity, for instance, the cheese powder may begin to clump, reducing its dispersibility and leading to uneven coating. Worse still, excess moisture can cause the puffs to begin absorbing water from the air, softening the texture and compromising the crisp, dry bite expected by consumers. To prevent these issues, HVAC systems specifically engineered for food processing environments are deployed throughout the Cheetos plant. These systems do more than just heat or cool. They dehumidify, filter, and exchange the air in sensitive zones at rapid intervals, ensuring a constant flow of purified, dry, temperature-stabilized air. Some areas, such as the seasoning tumblers or the vertical form-fill seal zone, may be isolated with positive air pressure to ensure that external air, dust, and contaminants do not seep into these critical zones. These environmental systems are integrated with digital controls that feed data into the facility's central monitoring hub. Temperature and humidity data are tracked every few seconds, and if any reading moves outside of pre-programmed tolerances, automatic alarms notify technicians to investigate immediately. In some cases, the system will even halt upstream processes automatically to prevent production under unsuitable conditions, protecting product quality. While environmental controls maintain external conditions, another system ensures the quality of what's happening on the line, inline quality assurance, and real-time analytics. Throughout the Cheetos line, from extrusion to bagging, dozens of sensors, scanners, and cameras work in unison to gather data on key quality metrics. These include moisture content, oil absorption rate, puff size, color uniformity, seasoning coverage, and weight per unit. Each of these factors contributes not only to taste and mouthfeel, but to customer satisfaction and regulatory compliance. Advanced laser micrometers and stereo imaging cameras measure the dimensions of each puff as it moves across the line at high speed. If puffs fall outside the programmed size range, either due to inconsistent extrusion pressure, die blockage, or improper cutting, those units are flagged and rejected automatically using pneumatic diverting arms. Simultaneously, optical sensors inspect the color of the fried puff to confirm it matches brand-specific targets. Color variation could indicate improper frying time, fluctuating oil temperature, or oil degradation. The system will trigger alerts or shut down sections of the line if it detects drift from acceptable limits. Another important part of inline quality is the metal detection system. Every snack must pass through high-sensitivity metal detectors or, in some cases, X-ray systems just before packaging. These devices scan for trace amounts of ferrous, non-ferrous, and stainless steel contaminants which could originate from worn machinery parts, upstream, or during maintenance. The sensitivity of these machines is such that they can detect metallic particles smaller than a millimeter in diameter. If a contaminated bag is identified, it is automatically ejected from the line, recorded in a digital log, and sent for root cause analysis. In high-output snack manufacturing, product changeovers are another critical concern. A single plant might produce multiple Cheetos variants: classic cheese, flamin' hot, jalapeno cheddar, and limited editions on the same line, sometimes switching several times per day. To avoid cross-contamination of flavor profiles and allergens, the factory must execute a full product changeover, which includes both physical and procedural steps. The final bags of one variant are run through the line until the seasoning and product types are completely cleared. Following that, dry cleaning and wipe-down protocols are enacted on exposed surfaces. In flavor tumbler zones and powder feeding systems, residue removal is handled by a combination of mechanical vacuums, compressed air nozzles, and in some cases, wet cleaning cycles. Pipes carrying seasoning powder are often disassembled and cleaned manually or flushed with air-driven pigs, foam or rubber projectiles that scrape the interior of the tube clean as they are propelled by compressed air. All cleaning steps are verified through ATP, adenosine triphosphate, swab tests or allergen-specific strip tests to confirm the line is ready for the next product. Equipment cleaning and sanitization extend far beyond changeovers. Each section of the production line is scheduled for deep cleaning on a regular basis, with some components cleaned daily, others weekly, and critical systems, like oil fryers, undergoing monthly shutdowns for intensive maintenance. Every cleaning task is documented in a digital sanitation log that includes time-stamped photos, chemical usage records, technician ID, and verification by a supervisor. This log ensures compliance with food safety regulations and internal auditing systems. Speaking of oil fryers, one of the more maintenance-intensive systems in the Cheetos plant is the oil management setup. Used frying oil is constantly cycled through multi-stage filtration systems that remove fine particulates and oxidized residues. Inline sensors monitor oil color, free fatty acid content, and total polar compounds, all indicators of oil degradation. When thresholds are approached, fresh oil is introduced, and a portion of the old oil is purged to waste recovery tanks. This spent oil is not discarded haphazardly. Instead, it is captured and sent to third-party processors who refine it for use in biodiesel production or industrial lubricants, creating a closed-loop waste management process that supports sustainability goals. Seasoning systems have their own challenges in terms of dust and waste control. Cheese powder and spice blends are notoriously airborne, so extraction hoods fitted with HEPA filters are positioned above tumblers and conveyors to capture stray particles. These systems not only keep the air clean for workers, but also prevent buildup on surfaces and reduce cross-contamination risk. Powder recovered in this way is not reused in production, but is collected and weighed for waste tracking. Many factories monitor seasoning powder yield versus usage to optimize application and reduce excess without compromising flavor intensity. Additionally, factories employ floor-level waste segregation systems, where organic waste, such as broken puffs or overcooked batches, is separated from packaging materials and cleaning byproducts. Organic snack waste is often sent to animal feed processing plants or used in anaerobic digesters to generate energy, while plastics are compacted and shipped to recycling partners. These systems not only reduce landfill usage, but also lower the facility's total environmental impact per unit of product. Every phase of the factory's operation is governed by a robust system of documentation and auditing. Real-time production data is logged into the Manufacturing Execution System, MES, which connects to the plant's Enterprise Resource Planning, ERP, platform. This system allows plant managers to track every batch of Cheetos from cornmeal input to palletized output. If a quality issue is flagged post-distribution, every input, cornmeal batch, oil lot, seasoning blend, even the operator ID can be traced within seconds. This level of transparency is essential for large brands that operate under continuous scrutiny from regulators, retailers, and consumers alike. All these systems, from the air handlers and fryers to the conveyors and flavor blenders, are monitored by a central control room staffed by trained process engineers and operators. The control room acts as the nerve center of the factory. Touchscreen interfaces display real-time data on line performance, yield percentages, waste figures, and energy usage. Alarms and alerts notify the team of any deviation in pressure, temperature, fill levels, or machine health. The staff can make remote adjustments, schedule maintenance tasks, and even initiate partial or full shutdowns directly from their stations. In many facilities, predictive analytics platforms are integrated into these systems. Using machine learning algorithms, these platforms analyze historical and current data to forecast when a component might fail, how yield might shift under ambient changes, or what impact a change in oil temperature might have on puff expansion. This allows for proactive decision-making, reducing downtime and maximizing efficiency